This is example 3 on day 2 of rational functions notes. So our first step is to factor both the numerator and the denominator. So our numerator is fully factored. Our denominator is the difference of two squares. So x minus 4, x plus 4. A good habit I like to get into just to remind myself that it's a factor and I can't cancel out unless there's multiplication is putting parentheses around the factor in the numerator. So even though this gives this order vertical asymptote, horizontal asymptote, slant asymptote, x-intercepts, y-intercepts, wholes, we can still do this in any order. So what I always do first is I look to see if we have a whole. What we look for a whole is, do we have a factor that divides out? So here we do have a factor that divides out. It's x minus 4. So I think about the x value that would make this factor equal to 0. That's 4. And then down here, I want to think for my whole, I want to evaluate my reduced function. So looking back up here, I need to remember that this has an implicit and understood 1. So my reduced function is going to be 1 over x plus 4. So if I want to evaluate f of 4, that becomes 1 over 4 plus 4, which is equal to 1 over 8. Okay, again, I'm putting this so that you understand where I'm coming from. If you can do that as mental math, you can go right here. So the next thing that I'm going to look for is I'm going to go back to my factored function. I saw that I already divided out the x minus 4. So for a vertical asymptote, I'm looking for any other factor in the denominator. So here I see x plus 4. So the value of x that would make this equal to 0 is x equals negative 4. A vertical asymptote needs to be an equation of a line. Okay, so if you don't have the x equal, this is incorrect. Okay, so looking at this, you want to make sure you have x equals negative 4. And again, you're just looking for what value makes any remaining factors in the denominator equal to 0. So next we're thinking about our horizontal asymptote. So again, we want to think about the degree of the numerator. And then we want to think about the degree of the denominator. And we want to compare those. Okay, so I always look at the original function just in case I made a mistake here when I was factoring, but the degree of my numerator is 1. The degree of my denominator is 2. Since the degree in my denominator is bigger, that means I have a horizontal asymptote at y equals 0. Okay, so again, the y equals is important. If you don't have the variable there, you don't have an equation of a line. Okay, and so you need to make sure that you have the y equals. So for a slant asymptote, the degree in the numerator needs to be 1 greater than the degree in the denominator. That's not the case here. So for our slant asymptote, we have none. For our x-intercept, we are going to take the numerator of our function, of our reduced function, and set it equal to 0. So for our x-intercept, our reduced function numerator, right, here's our reduced function, is 1. 1 equals 0. That's never true, so we have none. We don't have an x-intercept. And then for our y-intercept, we're going to find f of 0 from our reduced function, which would be 1 over 0 plus 4, which is 1/4. So our y-intercept is going to occur at 0, 1/4. Okay, So looking at all these values, right, it doesn't seem like we need to change our scale, but we also don't have many other x values. So what I'm going to do, I know that at -4, I have a vertical asymptote, so it's undefined. So I'm going to make a table with -5, -6, and -10. And then I'm also going to include in my table -3, -2, and I'm just going to do 5 and 10. So -10, -6, -5, -3, -2, 5, and 10. Okay, so take a pause for a second, use a calculator, okay, or by hand and figure out all these values. You can use the reduced function. So I have my table here. So it looks like none of my y values actually get bigger than 1 or less than -1. So I think what I'm going to do is I'm actually going to make my scale, I'm going to make this 5. There are other values that could work. I'm going to make this -5. And then I'm still going to keep this with 10 and -10. So I need to draw in my vertical asymptote at x equals -4. So for vertical asymptotes, we put in a dotted line. And then we have a horizontal asymptote at y equals 0. Y equals 0 is our x-axis. I usually try it's really hard to see, I feel like. So I usually try to extend it a little bit on either side so that I can see it. My y-intercept is at 0 1/4, so that would be right about here. My hole is at 4 1/8, so that's going to be really close to my y-axis. So looking at some of my other values, I have -10, -1/6, -6, -1/2, -5, -1, -3, 1, -2/2. Oh, 1 should be up 1 because I changed my scale. -2/2, and 5 1/9, and 10 1/14. Okay, so this is kind of good evidence. I can see that my points on the left and right end are getting closer and closer to 0, which makes sense for my my horizontal asymptote. And then you could do the math to see the arithmetic to sort of see what's happening on either side of the vertical asymptotes, but I think you'll notice that if you connect these points, okay, they're going up. So to continue this branch, you would go here, and then if you connect these points and continue, right, you want to be getting closer and closer to here. Okay, so our domain, we start at -infinity. Our first discontinuity is at our vertical asymptote, which is at -4. We pick up again and we're fine at -4. Right after -4, we're continuous again until our hole, and our hole is at +4. And then we're continuous again until infinity. Okay, and then the other thing that we might want to think about when we're doing these is just our end behavior. Sorry, I'm just looking for some space. So remember, in behavior is x always equals negative infinity and x equals positive infinity. Hopefully from the graph you can see this is y approaches 0 and y approaches 0. And then sometimes they might also ask us for behavior around a vertical asymptote. So our behavior around a vertical asymptote, so we want to think about where the vertical asymptote is. So this would be as x approaches negative 4. So as x approaches negative 4, and we want to think about the left. So looking at negative 4 to the left, y is approaching negative infinity. And then if we want to think about x approaching negative 4 from the right, right? So here's negative 4 from the right. Our graph is going up to infinity. Okay, so when I finish, I always look through and make sure, did I mark my hole with an open circle? Yes. Did I mark my asymptotes with dotted lines? Yes. Was I consistent with my scales? Yes. Did I plot my points correctly? Is my graph as clean as I can make it?